Alrighty then, corn children, children of the corn. This is a how-to video, not a how to improve your life, although perhaps this will, but how to find f prime, the first derivative of f, using the definition of the derivative, which begs the question, what's the definition of the derivative? Well, luckily for you, in a previous video, we went through where this definition came from. There it is in all its glory. F prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And we are going to use that definition to find the derivative of that there function. All right? So this is a how-to example video. All right, let's do it. Pause as you need to, go back, rewind, you know the drill. All right, so I know it's redundant, but I'm gonna write that down again. I know, you'll get over it. Limit delta x approaches 0. Mrs. Klein, do I have to write that every time? You do until we actually let delta x go to 0. Yes. I don't want to. Suck it up. All right, so here's our definition. Limit delta x approaches 0. All right, first off, f of blah, blah, blah. Well, let's remember what the Haiti-ho this means. If I had f of 7, that would mean in this function, I would take the x out and replace it with a 7. Yeah? 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 Can you picture it? 7. 7, right? If it said f of cat, then in parentheses we would put a cat so that the entire cat would be squared. Ugly but true. All right? Well, here's what they want us to put in. They want us to put in x plus delta x. All right, so here's what I'm going to suggest, / command. You ready? I'm going to write our function down, but I'm going to take the x out and use parentheses to create a space. 3x squared minus 4. Can you see that that is our function? The x has been removed. In the place of the x, we will put x plus delta x. X and a little bit more. All right, so that right there gets me to this parenthesis. Then it says minus the original function. So here's my minus, and here comes the original function, 3x squared minus 4. 3x squared minus 4, all over delta x. Now, I have made a mistake. What? I did it on purpose. This is a learning moment. Are you ready? There's a problem right here. Why? It was minus the whole function. So if I'm going to write minus this function, I would need to put parentheses here. So you can put parentheses here and then distribute the negative. Or if you're smarter than the average bear, you could distribute the negative. This becomes a negative 3x squared and a positive 4. And because I am that smart, that's what I'm going to do. So I'm going to drop my parentheses, but distribute the negative. So now this is the negative on the 3x squared plus 4x. Booyah. All right. Now, you might say to yourself, well, let's go ahead and let delta x become 0. I mean, if we fill that in, this will make it a lot simpler, right? So if we make this delta x into a 0, this would be 3x squared. Minus 3x squared, those would cancel out. And then minus 4 and a plus 4. And those would cancel out, and the whole numerator would become a 0. And delta x in the bottom, that delta x would also become 0. Oh no, 0 over 0, what do we do? Dig deeper. Now, if you need to go back and watch an old video on what do we do if we get a limit with 0 over 0, go ahead. But bottom line, here's what I'm looking to do. I am looking to factor, cancel, and plug back in. Does that sound familiar? Hopefully it does. In. All right, so because of the 0 over 0 case, we cannot directly substitute in the 0 yet. We'll do it again after we factored and canceled. So how are we going to factor and cancel? Well, bottom line, we're going to have to multiply this thing out. All right, now let's be careful here. Are we allowed to simply square square? No, no, no. Should we distribute the 3 first? No, no. Here's what we do. We're going to do x plus delta x times another x plus delta x. Now, just stick with it here. I'm going to do that on the side of my paper. Right here, I'm going to do the x plus delta x times another x plus delta x, slowly and carefully, this time for you. In the future, I will just write down the answer. If you have an x plus delta x squared, that means that you have an x plus delta x times another x plus delta x. And now we need to multiply it out. We're going to do x times x, x squared. We are going to do x times the delta x, x delta x. We're going to do another delta x times x. Order doesn't matter, you're multiplying. And then delta x squared. And you can see the little foil man. Hello, little foil man. That's excellent. We can combine these two. They are like terms. I have one of these and one more of these. That makes 2x, delta x plus delta x squared. Now, I don't do this for real when I'm doing this alone. You square the front, you square the back, twice the product of the two. Square the front, square the back, multiply them together, and double it. That's the shortcut for perfect squares. All right? All right. So now, come back with me here. I'm going to put this in place of that. I still would have to distribute the 3 though. Limit delta x approaches 0. Here we go. X squared. 2x delta x squared. Then the minus 4, then the minus 3x squared plus 4. All over delta x. Distribute, distribute, distribute. This is fun. Woo! Distributing through 3x squared, 6x delta x, 3 delta x squared. Bring it down, bring it down, bring it down. All right. Now look at that numerator. Do you see what I see? Do you see what? Oh, 3x squared minus 3x squared. Silly 3x squared. Those cancel out. Oh, look again. Minus 4 plus 4. Those cancel, silly 4s. Hey, look what happened. It's almost as though all the terms that didn't have a delta x canceled out. I wonder if that happens a lot. Yeah. Remember our goal back over here was to factor, cancel, and plug back in? They now have, the remaining terms have something in common. They both have a delta x. I know they also have a 3 in common. I don't even care about that. The goal is we need to get this delta x to cancel. So we have to factor the delta x out. It is delta x that is going to go to 0. So it is the delta x that we factor out, leaving behind a 6x and 3 single double x, or delta x, all over delta x. That's your factoring. Do you see it? It's factored. Not factored? Factored. Now that it is factored, we can cancel. So here we go. Limit delta x approaches 0. That was the last time through, people, with the limit statement. Because now what we're going to do is we are finally going to let delta x go to 0. Not x. No. Delta x goes to 0. Well, if delta x goes to 0, 3 times something going to 0 drags that whole term off to 0. It gets so close to 0 that we ignore it, and we get just 6x. The derivative of f is 6x. Whew!